So let's just save our files. The name of the project is going to be a simple call center system. Okay. Now we are going to start with of course, create process, right? So the customers, the callers are going to arrive. The callers are going to arrive with a create process. So let's double click on that. And we say that the name of this module is create call arrivals. Now, this is going to be a very long project, my friends. You need to be very careful in writing these names. One misprint, one misprint can create huge errors in your simulation project, which you will not be able to compile. And sometimes we will not be able to find that error very easily. Okay. So you need to be very careful when you are writing the names here. For example, which type of entity that we are creating here? The entity type that we are creating here is an incoming call. Okay. So we create call arrivals, and the entity type that we create here is incoming call. What is the time between the arrivals? So according to the text, the arrival times are exponentially distributed with 0.857 minutes. So we have exponential inter-arrival times. At each arrival, the time between the arrivals is average time between the arrivals is 0.57 minutes. Okay. And entities per arrival is what? 1. At every arrival, one caller is arriving. And at this point, we need to write something here. Maximum number of arrivals. Are we going to allow arrivals after 6 a.m.? I am sorry, 6 p.m. If you remember, we are not going to allow any arrivals after 6 p.m., right? So nobody is going to arrive after 6 p.m. So here I will say entities per arrival as, instead of that, entities per arrival is going to be a variable that is called calls per arrival. Okay. And the maximum number of arrivals is going to be another variable, V max calls. Now you will ask me why we have written a V in front of these names. I'm just going to define these two variables as a system variable. Okay, they are going to be system variables. The number of calls per arrival is going to remain as 1. It is going to remain as 1. And maximum number of arrivals is going to be remain as infinite at the point. Okay, so in fact, let's just leave that to a later time. Okay, let's just leave that to a later time. So let's just say this is equal to 1 and this is equal to infinity. Okay, so I do not want to complicate things at this point. So this remains as infinity, and the first creation is going to occur at, let's just say, at an exponential inter-arrival time again. But I mean, the textbook usually leaves this as 0. So instead of writing the exponential inter-arrival time with this mean again, let's just keep it as 0 at this point. So right now, at each arrival, one arrival is going to occur, and a total of infinity arrivals are going to occur. And then we are going to change these, remember, change this, but not this at this point. So this is my process where I create the arrivals, okay? Now from run window, from setup, I have my replication parameters, and I would like to change the base time units to minutes because every distribution parameter that I am going to enter will be given in the minute to time units. So I click on OK. So I have created the arrival process. Okay. So what is the next thing that I am going to create? So the next thing that I am going to create is the record module. So what do I do in this record module? Let's see. So from here, I am going to introduce a record module, and the name of this record module is going to be record attempted call. okay? And in this record, I am just going to count. So in record, what we do basically is to collect statistics. And this time I am just going to collect a count statistic. So what do I count? I am going to count the number of attempted calls, okay? Number of attempted calls which can or cannot enter the system, okay? So whether they are going to enter the system or not, it doesn't matter. This is just going to count the number of calls throughout the simulation, okay? At every entrance, at every call, that count is going to increase by 1, and the name of the calls, the name of this variable, the name of this counter statistic is going to be attempted calls. So every entity that enters the system, every call that enters the system, either will catch a trunk line or not, okay, either will catch a trunk line or not, is going to increase this statistic by 1, okay? Everything that enters is going to increase this statistic by 1. Now, after that record, I am just going to enter a decide module. And the name of the decide module is going to be this: trunk line available. Now, if my friends, right now, in the system, if there are 26 clients waiting in the system, then there will be no trunk line available. But if less than 26 clients are in the system, if the working process in the system is less than 26 clients, then there will be a trunk line available, okay? So this time we are going to write a condition. It's a two-way by condition. The answer is either going to be yes or no. If the answer is yes, then we are going to enable the caller enter into the system. Otherwise, if all 26 trunk lines are busy, in that case, the client will not be able to enter the system, okay? So we are going to define a condition here, a condition based on an expression. So we are going to write an expression here. If this expression is true, then the entity is going to enter the system with a true answer here. So if the condition is satisfied, then the callers are going to enter the system. Otherwise, the callers will not be able to enter the system. Okay. So I need to write an expression here. Okay. So what type of expressions that I can use here? I can use, so right now we do not have any resources, right? So we do not have any resources. So I am going to explain this later, but at this point, let's write this expression in comments. The number of busy trunk lines if this is less than the scheduled trunk line, okay, the number of busy trunk line. So NR means number of busy trunk line. If it is less than the number of scheduled trunk line, then the answer is going to be yes, there will be a trunk line available. And in that case, the caller can enter the system. So this is my condition at this point. And I am just going to leave it as it is. And then I am going to re-explain this to you when the time comes. Okay? Okay, now if the trunk line is available, if that condition is satisfied, the expression in that condition is satisfied, then the customer is going to enter the system. And after the customer enters the system, then the customer is going to see the trunk line. Now, remember now, when we define a process here, we have different actions here: delay, cease delay, and delay release. Now at this point, if a client can enter the system, that client is just going to seize a trunk line. There will be no process at the beginning. Just seizing a trunk line. Trunk line is a resource. And the capacity of this resource is what? 26. Now, any client who can enter the system is going to seize a trunk line. Now, we need to introduce a seize module here, not a process module, but instead we need to use the advanced process panel. So from file, I say templates panel and attach the advanced process panel here. Now, in the advanced process panel, if you go to letter S, we have seize module. So I'm just going to introduce a seize module here. Okay. So I'm just going to connect that decision module's true answer, the exit for the true answer, to the seize module. And I will change the name of the seize module to seize trunk line. Okay. So it is going to be named as seize trunk line. Okay. And we need to seize the which resource. So we are going to define a resource here to seize. The name of the resource is going to be trunk line. So every client that goes through the seize process is going to seize one trunk line, and then we click OK. And we have a queue here, which is seize trunk line queue. However, because the people who will not be able to find any trunk line available will not enter the system, we will never see that queue. So if there is a trunk line available, then the people can enter the system. Therefore, they are not going to wait any time. But if there is not a trunk line available, they are not going to enter the system in any way. So they are going to leave the system with this false exit. Therefore, they are not going to be a part of the queue. So we basically see the trunk line at a quantity of 1. So if you click on that, under the basic process panel in resource spreadsheet view, we will have a resource that is called trunk line. And how many trunk lines do we have in the system? 26. So I am just going to change the capacity of the trunk line to 26. Okay? Now coming to that point, coming back to that decision module here, trunk line available. So I am just going to rewrite this expression. So now trunk line is defined already. The trunk line is defined already. I am just going to build an expression. If this condition is satisfied, then the customers will be able to enter the system. So what is that condition? I will say build expression, and I will say that about that condition is defined on the resources. If the number of current number of busy trunk lines. So because there is a single resource I have defined right now, it is automatically written here. The current number of busy trunk lines, if it is less than the current number that is scheduled, and the current number that is scheduled is 26, then a client will be able to enter the system. But instead of that, because you know that there is always 26 trunk lines available in the system, you can simply write 26 here. However, I mean, if you change the number of trunk lines available throughout a day, for example, in the beginning of the day, you can start with 26 trunk lines, but in the afternoon, you can work with, for example, 30 trunk lines. If you make such a change, then you need to write the current number that is scheduled here. Okay, so I say current number that is scheduled here. So let me start from scratch. The current number that is busy, if this is less than the current number scheduled of trunk lines, which is number of busy. So NR means number of busy trunk lines, and MR means number of scheduled trunk lines. If this is less than that, then the answer to this decide module is going to be true. And if the answer is true, then the client is going to enter and see the trunk line. And for example, if we have 25 seized trunk lines already, if 25 of them are busy, and if we have a client incoming, that client is going to enter and immediately sees a trunk line, and the number of seized trunk lines is going to be 26. After that point, a new client will not be able to enter. Okay? So this is how we define the entrance process, how we are going to allow the people to enter and not enter. Okay? So we have defined the trunk lines here. Now, I am just going to add a attribute here. I'm sorry, not attribute, but I'm going to introduce an assign module here. And the name of that assign module is going to be increment active call counter. Okay. So I am just going to define a variable here for the first time, a system variable. And the system, the variable that I'm going to define here is going to be called vTotal WIP. All entities that go through this assign process is going to increase vTotal WIP with 1. So the new value, the new value of the variable is going to be 1 more than the previous value. So this is going to be new value. So you see, if an entity goes through this assign module, then there will be a variable which is called vTotal WIP is going to increase by 1. Okay. So that is the change that we are going to apply in this assign module. Okay. So if you click on, so because of that reason, it is called increment active call counter. Default values of all variables, default values of all attributes that you define is always 0. Okay. So this is the default value, but it is going to change throughout the simulation with every entity that is going through that assign module. Okay. So this is just the default value, but you can change that default value. For example, you can start it with 5. So right now, in the beginning of the simulation, the total WIP variable can be 5, but we do not change it. We remain it as it is. So it is going to remain as 0 in the beginning. Okay. So that is a real value, and it's a system variable, v total WIP, the total number of. So we are going to add another SM module just before the exit. Before the exit, they are going to decrement. Instead of increment, we are going to decrement the total number of work in process entities. Okay, right now we just increase it. So we are basically following the total number of entities in the system. Now, after this increment module, I am just going to add a storage module. Okay, a storage module. So from the advanced process panel here, I have a store module here. I am going to check that here. So I will say there is a storage here. Okay. So I'm just going to explain why do we use store module. So there's an explanation to that. But at this point, I'm just going to do whatever the book is saying. Then I am going to explain why we have used this module. So the name of this store module is going to be store for initial recording delay. Okay, store for initial recording delay. And that is a storage. And the name of the storage is initial recording delay storage. Initial delay storage. I am going to explain why we have done that. Okay. So we have stored the entities into initial recording delay storage, and the name of that storage is initial recording delay storage. So why we have done that? Now, my friends, you see when we read the process here, a caller who can catch a trunk line is going to listen a recording. It is going to listen a recording, and that recording is going to describe which type of process or request that the client is going to get. And that process is taking a uniform distributed amount of time, which is between 0.1 minutes and 0.6 minutes. Now, in fact, I could have done this instead of using that. I could have done this with simple process, with a simple process module here. And I could have written process as initial recording delay. And because this is an automatic hearing, recording hearing, automatic record hearing, it is not going to utilize any resource. Everybody, they are just going to enter this process and delay, wait for an amount of time that is uniformly distributed in minutes between 0.1 and 0.6. I could have done it like this, okay? But if I connect that line to here, you will see no queue, right? So there will be no queue because there is not a resource to use. I mean, the queues in the processes can be observed when we have resources there. If the resources are limited, then we will see queues. If there are no resources to use, if the process does not require the usage of any resource, in that case, we are not going to observe any queues. And in fact, the queue animation that you see here is not observable here because this is simply a delay process. It is not seizing a resource or delaying a resource or releasing a resource. Okay? Now, if you do it like that, then you are not going to get any statistics from that process. So I would like to get statistics about the number of people who are in the initial recording delay process. Now, in that case, I should not use a process. Instead, I need to use a storage. Okay? I need to store these people into initial recording delay storage, and they are going to spend some time in this initial recording delay storage, and then they are going to leave that storage. Then I can get a statistic about that storage. Uniformly distributed in minutes, the minimum amount of time is 0.1 minute, and the maximum amount of time is 0.6 minutes. Okay, so there is a uniformly distributed, continuously and uniformly distributed delay between 0.1 and 0.6 minutes here. And after that, after the initial recording delay, we need to take these people out of the storage. Okay, so we have put them in the storage. The name of the storage was initial recording delay storage. Now, after they listen the recording, they need to get out of the storage. They need to get out of the storage. And for that, I need to use the advanced process panel, and I need to use the unstore module here. I am going to connect that delay process to the unstore. And in the unstore, here I'm just going to write the name of the unstore module is unstore from initial recording delay. Okay, and the type is what? Type is a storage. And from which storage I unstore this? From the initial recording delay storage. Okay, so anything that enters the storage here in the initial recording delay storage here, it is going to leave that storage after listening the recording. So we have a storage defined here. In that storage, I can collect statistics. How many, on the average, how many clients are waiting in that storage? I can basically trace this as a statistic in the end of the simulation. So this storage idea is a very, very good idea for processes, for only processes which are just in the form of delay, but not seize, delay, and release. Okay? Let me repeat again what we have done. So we have created call arrivals with inter-arrival times that are exponentially distributed with 0.857 minutes average. And at each arrival, one entity is arriving, and the maximum number of arrivals is the infinity. We are going to change these variables, make maximum arrivals and entities per arrival later when the time comes. Okay. Now, we have a recording module. We record the attempted calls. Every entity that goes through this record module is going to increase the number of attempted calls by 1. Okay, so attempted calls is a statistics that we collect. So we collect a counter statistic, which is called attempted calls, and it is going to increase by 1 with every entrance here. Then we ask this question: is trunk line available? And we are checking this condition. So this is a two-way by condition decide module. So the answer is going to be decided by checking that condition. And we need to write this condition as an expression here. If this expression is true, if the number of busy trunk lines is less than the number of scheduled trunk lines, then the answer is going to be true and the client is going to enter the system. However, if the client cannot enter the system, the client is going to leave the system immediately, but we are going to add that part later. And then the client seizes a trunk line. So trunk line is a resource that we defined here. It seizes a single trunk line at this point, and after seizing it, it is not going to release it. It is not going to release it. It is going to release it when before this client leaves the system. Okay, just before the client leaves the system, the trunk line will be released. Okay, so during the whole system operations, the trunk line will always be remaining as seized.